always something like that. It's always something like that. Hey, Ann, how are you?
I am doing well. Happy Sunday.
Yes, happy Sunday.
How are you?
Good. So let's go. Everybody here. Um, and nobody has any questions right now, but in the event that y'all do come up with questions, you can just email them afterwards and we'll talk. So the objectives of today are to, at a high level, reiterate what we talked about last week with the retrieving data, with those DML statements. We're going to talk about those on a high level. Um, and what I'm going to introduce to you all this week is logical operators, aggregate functions, and categorizing those aggregate functions. Also, we are going to discuss, or you are also going to apply limit, which you already do limit. You're also going to apply limit and order by within your result set. So let's get into our reiteration from last week. Last week, we spent the time with talking about those DML languages. What is DML language? Is that data manipulation language? Anytime you're doing anything within SQL, you're doing. Hold on, y'all. I am choking. I'm going on mute because I don't want to do all that on the camera. Hold on, okay?
Okay.
Okay, y'all going on mute too. Okay, I'm back. So last week we talked about those DML languages, the data manipulation language. We also talked about the importance of when you are within your database to do that data investigation, to be aware of those data types, those data dependencies. Remember, we talked about, okay, well, this column is related to that column. All of those things, we touched it on a high level last week. So this week, I'm going to reiterate so we can continue to build upon and progress into more advanced concepts. So let's start out with this select statement. What that select statement does is it retrieves their data from the database. Anything that you put after your select statement is what you expect to have within your output. Select star, that's their wild card. That's what it's called, their wild card. Give me all the data, all the records, all the columns. I don't care if it is a table with 50 columns in there. I want all the data. Select star from the table name. This is your database. This is your schema. This is your table. And we'll reiterate that as once we get within the database again as well. So this is your select statement. Insert. You all actually did this insert and this update with your coding challenge this week. I sent the create syntax and the insert into syntax, but it's essentially what this is doing. We're inserting into our table. We got to list out these columns. Then we turn around and say, enter these values within the columns. Insert into table, columns, values. Everything has to be aligned and everything has to go within that certain order. If not, then your data is not going to be inserted properly into the table and it can cause potential issues upstream. Meaning it can cause potential issues in the future that you don't even see at the time. Update. So we talked about that update statement. We're updating the table, set this column equals this value, set this column to this updated field where this condition is met, where this column equals John. That where statement, that is a condition all day long. If I tell you to go to the grocery store and get me some milk and you don't know me, you don't know what I want. But if I say, hey, can you go get me a gallon size of milk, almond milk, unsweetened, this name brand, when I provide those certain conditions to you, you have an expectation of what the output is supposed to be. You have an expectation of what kind of milk I want. So when a stakeholder comes to you and they say, hey, I need a data set of all the people that joined in this time period and that are from this city and that came on this day and it did this, those are conditions, because those conditions allow you to filter out your data. And this is important. I'm honing in on this today because a big portion of our session is going to be conditions and logical operators today and aggregate functions. So I want to kind of train your brain to say, when you see this where, it ain't nothing but a condition. It's the only thing it's saying is it's filtering down that data based on explicit X. That's it. Delete. Delete removes data from their database. It does exactly what it says it's going to do. Delete from the table name where this condition is met. Remember, when we apply our conditions and when we are retrieving data, when we're manipulating data, everything we do, everything goes back to a table or a column. You're not just randomly pulling data, and that's why it's important for you to do your data investigation as well. Go and look at your data. Go and look at your columns. Go and look at it and see how it's structured within a database. Because if your code does not match the way that the data is within a database regarding spelling, underscores, whatever, it's not going to know what you're talking about. Even when we have our where condition, like here, okay, y'all see it. Even when we have our where condition here, if I say where first name equals John, and I spell John differently than how it's actually within the database, it's not going to know what I'm talking about. So that's where their strong data investigation comes into play. That's where they're strong. Okay, what am I looking for? How do I retrieve it? Let's go and look and see what we're looking for. So any questions, y'all?
Yes, I have a quick question. Can you explain to me again why we have to use the single quotes?
Yeah. So let's talk about that. So when we think about the way that the data is structured within the database, the data, we have our columns and we have the actual data that populates that column. The data that populates that column fits into certain data types. We got our integers, we got our date time, we got all of it. However, if it is not an integer, if it's not a date time, if it is a what we call a string is essentially just numbers or letters. If your data is a string of data, this is how you classify it as a string, by putting those single quotes around it. So that's important. And that's a really good question, actually, because it helps you understand how things are structured. And that comes into play in session 3, where we're going to talk about manipulating string functions. You're actually going to be manipulating the values that's in the columns. And that's when you get into like that data transformation. But that's a really good question, because it essentially classifies that data. I'm letting the system know that this is a string. So if I put them single quotes, it's like, okay, this is a string of data. This is a string of data. It's not the column, it's the actual values that's inside the columns. But that's a good question, though.
Thank you.
You're welcome.
I have one question.
Okay.
Like, even when I was doing the, I guess the homework, you know, where you have select from and then you have insert into values.
Mm-hmm.
Is there any instance where we can take some like value, for instance, and put that value word where select from is? You know, going back and forth with, could we put select from where? Or select from values or set? Like, can you go back and forth with that? Or is it a set into how it is set up here?
Like right here, you saying, can you structure this any other way besides the way that it's already structured?
Right.
No.
Like taken from the other ones. Because my brain sometimes is telling me I'm doing select from it based on what they're telling me in the question. I feel like sometimes I could put where under that.
Like you could say like select, and then after your select statement, you list your actual columns.
Right. Right. And then you're doing from the same way it is, and then you're putting where under that.
Yep.
Yeah, okay. But
Yep.
could that go any other way other than the word where?
Well, it depends, because that's when you get into like let's say if I don't need to filter out any data or something like that. But where the way that it's structured, and as a matter of fact, now that I'm thinking through this, I can actually provide you with the structure from, if you get more advanced, because when you say select your column from this table, it'll always go like that. Then when you say where this condition is met and this condition is met, and when you incorporate even further things into like joins and group by and having, which we're going to talk about group by and having today, those things still have to be structured in order.
Okay.
If it's not structured in the particular order, it's not gonna execute.
Okay, gotcha.
So if that's what you was asking.
Yeah, because sometimes I don't know if I'm like creating my own structures sometimes.
Mm-hmm.
I feel like I am sometimes, and I think I'm taking it way too far than I need to.
Probably.
When I'm trying to answer questions.
Probably. And I think that once you get in the habit of, and that's why I like to use this session too, to reiterate like that foundational structure from session 1, because once you get in the habit of this has to be here, this has to be there, and it'll kind of it'll become muscle memory to you, to where I got to select from a table where this condition is met. And as we get even into aggregate functions, there's still other things that we have to put like even under from today.
Okay.
But it definitely has to be like in that order, because when you think about it, remove the code, remove all it. Let's think about the way something concretely reads something. Okay, you know the example that I told you from the grocery store. If I'm going to the grocery store and I have and I'm pulling certain produce, I'm pulling it from that table. So I got a whole list of produce that I'm pulling from a table or from a shelf. Now I got all the produce in my output, which is basically my basket, right? I got all my output, my produce in this basket. But the first step that I had to do is I had to select it from the table. Now I got all this produce in this basket that I selected from this table. That's when I'm going to start filtering. But in order for me to filter or specify which produce I need, I still got to take it selected from that table.
Right.
Then when you get into
together. Okay.
Yeah. Then when you get into conditions, I got all this produce in this basket. I want this produce where this condition is met, where that condition is met, where that condition is met. So when you think about how your brain naturally does stuff, you got to start from the biggest portion and you break it down based on it. So in this example, when we take it back to data, we're saying select these columns from this table. I can't say where anywhere other than after you done already retrieved the data. Because if I say where, I'm not talking about nothing. I got to pull the data first and then apply the filters.
Right. So my issue is where, like, I would have select from always. Like,
Yeah.
I was going that way. I was just adding the conditions underneath, but I was wondering if there's like different conditions that I could add in there other than where.
Yeah.
Based on what they were asking me.
Yeah, but it'll always start out with where though.
Okay, got it.
It'll always start out with where. Then you say where, then whatever your that's when you get into like your logical operators and stuff like that. But it's gonna always say select these columns from this table where. Then you go through.
Okay. Thank you.
If you are filtering, but if you don't need to filter, you don't have to have a where. Like let's say within our aggregate functions, we might not filter. Or let's say within our joins, we might not have to specify a data set. We only want like a certain output of data. So if you are filtering, like meaning if you are coming within the data and you only need a subset of data, that where is going to be there all the time.
Okay.
Yep, that's a good question too. And I like when y'all ask stuff like that because it helps me like understand where you at. So let's get into any other questions. Okay. So let's get into our logical operators. Okay. So let's get into our logical operators. So what are logical operators? Logical operators are essentially where you have the opportunity to combine multiple filters. That's when you get into what we call like that advanced filtering part of analysis. I'm choking again. Hold on, y'all. Okay. So logical operators allow you to combine multiple conditions. Now, we talked about conditions last week and we talked about conditions a little bit this week. A condition is essentially like, how do I want to filter out this data set? We talked about select these columns from this table where this condition is met. That's the condition all day long. A logical operator allows you to add multiple conditions to that one condition. You're essentially stacking conditions. And what that does is it allows you as an analytic professional to be extremely specific in what your expected output is with your data set. What does that look like? You get an ad hoc request or you are building out the script for that connects to a dashboard and they only want to know certain conditions. They only want to know how many patients saw this doctor on this date. They only want to know what's the average cost of this on these months. They only want to know certain things within their data set. And why is this relevant? This is relevant because it helps you as the analytic professional make that data more useful. When I have 2 million, 3 million records of data, I cannot give a stakeholder 3 million records of data with no analysis, no cleansing. I don't know if it's good data. I don't know the relationships. I don't know anything. I can't give them that. Why? Because it's not useful. And your analysis and your presentation is only as valuable if the person that you are creating it for can make sense of it and can consume it. If you just giving out millions of records of data and they don't know what the relationship is, or I can't draw any conclusions or recommendations, you should have just kept it. It ain't worth nothing. So that's where those logical operators, hey, Monica, that's where those logical operators come into place because it allows you to be super specific in what you are retrieving within your data set. So let's talk about logical operators. Let's talk about and. Looking at this code here, what do you think that this line of code is doing?
It looks like it's pulling two.
Okay.
From the department, like I guess 2 columns.
Mm-hmm. What is it doing? What do you think it's doing?
It has to meet those special conditions.
Mm-hmm.
Like the IT department and the salary has to be greater than 50,000. So
yep,
it has to meet both of those conditions.
Yep. So the ask is probably along the lines, look, can you give me a list of all the employees who are from the IT department and who have a salary of greater than 50,000? The ask will always be a qualitative X. But that's definitely the way to quantify it. I've selected all these columns, everything from this table where this department equals IT and this salary is greater than 50,000. And that output has to meet both of those conditions. It has to meet both of those conditions for it to be returned in that output. When you get into logical operators, we are getting into data filtering, which we talked about. We get into data filtering, but we also get into what we call is like the conditional logic. If this condition is met, then it returns this. So filtering and conditional logic is where like those logical operators come from. But that's exactly what it's doing. It's pulling it where both of these conditions are met. What do y'all think this one is doing, this line of code? These two lines of code here.
It's asking for some information, but one has to be this or that.
Yep. I'm retrieving all this data from this table where the department is IT or the department is HR. I'm good with either or. And has to meet both conditions or all. Because you can have multiple and. I can say where department equals IT and salary equals 50. And like I can keep going and going and going. Or does exactly what it says. Give me all of this data where this condition is met or that condition is met. So if it meets either one of those conditions, give me the data. What do y'all think this one is doing?
It wants all the information except for the employees that are in IT.
Yep. All the employees all the data except for the employees that are not in IT. Now, another way that you could probably, I'm trying to find my mouse. Oh, here it goes. I'm gonna write it in the chat. But another way that you could probably see this structure is just like this as well. If I say select, oh here, where am I? Oh, here it is right here, not. Okay, if I say select star from employees where, and I put that equal sign and that exclamation point, it essentially will act as like not. And it'll essentially say select all from employees where the department is not IT. So it can be used either way. And I see them used about the same. Some people say not, some people use the symbols. Between, what do y'all think this one is doing?
Selecting salaries between 40,000 and 70,000.
Yep. So this between conditional operator, what that does is it allows you to specify upon a specific range of data. It could be salary, like how we included here. It could be date ranges, like what we talked about. What that looks like is how many people joined in the year of 2024. You would have to do some research and figure out what that date range was. How many people joined on Q2 of last year? How many people are over the age of 65? Then you would use like their birthday and do some research and say, okay, well, if you're born on this day, you're clearly over the age of 65. Anytime you use a between function, or the between operator is what it's called, not a function. Anytime you use a between operator, I'm essentially telling you, I need all the data that is between these two values. And what do you all think this is doing?
It's including a list of things.
Mm-hmm. Yep.
So I'm assuming it will have to be two or more.
Yep. And
in order to use it.
Yep. And let's talk about what the difference between this in is and the difference between like a where is. So let's say I'm in a position and I need multiple values from each condition, from each column. Like here, we got select star from this table where this column in. So I want IT, HR, or finance. I want the values. If the values of that column is in any of these, it's going to return that data. So that's where you get into that value. What is the data? What is the value? What's in that column? What's the streams? Like Stephanie, the question that you asked earlier, which is why that was a great question because it feeds right into this one. What's the value? What's the streams from that data inside of that actual column? And not only that, but let's say, like you said, I need multiple values. I want them, if they are in IT, HR, and finance, I want it all. And I'm listing out the values that I know that we're looking for. Let's bring this back home. You're in healthcare. And you know that if a certain claim number, claim logic, diagnosis code, whatever, you're looking for certain diagnosis codes, but you're looking for multiple ones within that data set. That's where you would use something like this, because I'm looking for multiple values in that column. When you use in, it allows your data to maintain that structure, be clean. It allows for everything to just be super readable in the event that you do have multiple values. Everything just looks clean as opposed to saying, and this, and, just keeps everything super clean. Now, the beauty about logical operators is these can be combined. Like how I told y'all from last week. Last week, we learned the foundation. Everything that you do in SQL from last week on essentially builds upon it. It's a cake. You got your ingredients, you put your ingredients, you bake it, then you start putting your icing, you start layering your stuff on top of it. Now we're getting into the layering part. Why? Because your logical operators can build upon each other. What do I mean by that? I have select star from this table where this department equals IT and salary is greater than 50,000. I can come back and I can say, or department equals this and the date between this. I can build, my code can be, I bring stored procedures with 600 lines of code, 400 lines of code. You essentially take that foundation and you just build upon it. These logical operators, you can build upon these to filter out and be as specific as you need it to be. Because you are the analytic professional. So if you get an ask, it's your job to investigate that data and go and retrieve that data. So you can build out these logical operators. They can be combined, they can be whatever. But if you have that foundation, we're essentially building it right on top of it. And to this day, I'm 12 years in. I build my code the same way I teach y'all how to build it. I don't build anything from scratch. I teach the way that I teach y'all how to go do y'all data investigation and just build upon it. That's how I do it to this day. So anything you do, you can build right on top of this. Build it out. If you don't need it, comment it out. And that'll keep you sane. That'll keep your code clean, readable. It allows you to document it. And in the event that you got to come and be like, hey, can you look at my code? Hey, you go through the SQL repository and you see that there's already a project that aligns similarly to what you're doing at the time. Just build upon it. Build upon it. Any questions? All right, let's go then. Let's go then, because I like that. That means y'all know what y'all finna do. So if everybody is connected to the VM, is everybody connected to the VM?
I'm connecting right now.
All right.
Okay, I'm connected.
All right. Okay. All right. So today we are actually going to do our analysis within our healthcare system database. So that's the only information I'm gonna give y'all. I'm gonna walk you through. Once again, we're gonna go through here and do some housekeeping with like how everything is structured. But as far as this, okay, I'll make sure I want to show anything else. Okay, but as far as that is the only thing I'm gonna tell y'all today. But I'm gonna guide you.
I'm sorry, how did, I think I missed this step. How do I get that? I clicked on databases.
Oh, this don't look at this. Just, yeah. So are you in here though? Are you in SQL Server?
Yes.
Okay, cool. So let's walk through everything again so that we can reiterate like how things are structured within the database. This is your server. The server is the brain of everything. Your server down. I had an issue at 5 o'clock this morning. Your server down, it's just everything down. People can't get their data. The apps can't get their data. The website can't get their data. Like I said, the apps that are attributed can't get the data. I think it was estimated that when our server is down, we lose like $50,000 or something every 30 minutes or something. It's crazy. It's crazy because people can't access it. It's super important. So it keeps everything structured. Expand your server. These are your databases. We got our server. We got our databases. Our databases essentially house all relational data. What I say we were going to be doing? Oh, healthcare. Okay, so we're going to go within our healthcare system database, expand it, and you'll see your database diagrams, your tables, your views, everything is in here. So you got your server, your database, and then you have your tables. Remember, everything that we do with this SQL goes within tables and columns. So here go your tables right here. Now, in order to do some data investigation, you can do two things. You can click on it and expand your columns, expand your keys, and it'll tell you what these columns are. Here we got our appointment ID, PK, integer, not null. PK means primary key. That means that is the unique identifier within that table. Integer, the integer data type. Not null means it is required. It can't be null. Then you can open up these tables and you can take a look at any of the relationships. This is where you get into those database relationships. We got that data relationships. Just open up. You can do your data investigation like this if you want to just take it a high level look at how these tables are related. What's the relationship? It's no different than how people are related. What's the common field or the common, like people have common relatives. What's the common relative between each of these tables? That's when you get into those data relationships. Now, this is your one reason or one way to do your data investigation. Go and look. You literally investigating. Go and look. Another one is if I have an idea or if I get a data request, like how I'm about to ask y'all, I get a data request and I open up my tables and I look at all my columns here. Another way to do it, and I say, oh, well, I think we're going to use this table. You right click it and select your top 1,000 rows. And that will select top 1,000 from your table. This is our database. We in the healthcare system database. Healthcare system. This DBO, this is our schema. The DBO is like what the system automatically calls the schema. But you can make your schema anything and what the purpose of this schema is to organize those tables within the database. Because you can have 50 tables, 60 tables. And if you want to organize those tables by, let's say, a project, you can make your schema be anything you want it to. And this is your table name. When you right click and select your top 1,000 rows, that will give you visibility to those strings and those values. Get back to Stephanie's question. Those values. That's why I keep saying it's such a great question, because it brings you back to those values that's in that data, in those tables. Because in order to navigate that space, your data types have to match, aka it has to be a string if it is a string, and it has to be structured the same way, meaning it has to be spelled same way, all the other stuff. So data investigation, open up, expand your columns is one way to do your data investigation. Another way is to select top 1,000 rows and it'll retrieve your data. Any questions? Okay. Now, we are in our healthcare system database. I am going to give you all a use case. I'm going to give you all a use case. I'm going to type it in the chat. And I'm going to say it out loud too, so that in the event when you go back and look at your recording, you'll have it. I'm also going to have this screen pulled up too for y'all. The logic operator, so you can use it as a point of reference. So let me look at the data, because I had it up there, but I moved it because I didn't want to show y'all. And if you get caught up on something, please walk through it, share your screen, let's talk through it. Ain't nobody gonna judge you, ain't nobody gonna think nothing wrong. We're all learning this together, and your questions might very much so help support someone else's. Also remember, when you are doing your use case, to document what you're doing. What do I mean by that? Whatever my use case is, I come right here, I do my two dashes, and I say this query retrieves records that X, Y, and Z, whatever your condition is. That way you know what you're doing. And it's also best practice too. So this is your technical assessment. Okay. 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 All right. So the use case is I need the patient ID, test date, and result of tests where the result is abnormal. The test date is in the year 2024, and the test date was an MRI, blood test, or ECG. It sounds like a lot, but let's start from our very first step, doing our data investigation, figuring out which tables answers this question. That's your first thing. Which table answers this question? Step one, data investigation. Which tables answer this question?
You want us to tell you?
Give them a few minutes. You know already.
I think I do.
You probably do. What is it?
It's a medical test?
Yeah. That's it.
Cool.
Come through. Now, got your data investigation out the way? Now, right-click that table, select your top 1,000 rows, and start building out your syntax to answer those questions. Take line by line what they want. In order to eat an elephant is one bite at a time. I don't know why I say that. I heard somebody say it and I cringe. It's so cringy. But it makes sense though. Line by line, what is this person asked for and what's the most appropriate way to format it using my logical operators? And I'm gonna write it with y'all. Make sure you document your code because in 2 weeks you come back, you're not gonna know what you're working on. And your teammate might see your code too, and they ain't gonna be able to know what you're working on. But I'm about to go on mute because I talked through my stuff. Bye. Okay, select. Okay, this query retrieves the. Also, if you need to nudge or need some help, just nudge or post it in the chat or whatever, and we'll talk through it. Records that retrieves the patient ID, test date, and result of where the result is abnormal and the test date is in the year of 2024. Told y'all I'll be talking through my code 2024. And the test is MRI blood test or ECG. I did not mean to unmute, but I was trying to say something because I was walking through it and I could see how the test type, the test name could be confusing. When I say MRI blood test or ECG, I mean either one. It can be. I want it to be all of those. Test name is MRI blood test and ECG, not or. Okay, I'm going back on mute. I just caught that because I was working through it too. ECG. Okay, where? Okay, so I need the patient ID, test name, patient ID, test date, test name, and result. Okay, where? Okay, result is abnormal. Result equals result equals abnormal. Where the results at that test date and test date between, let's say 2024, 2024, 01, 01, and 2024, 12, 31. Okay. And test date between and test name and MRI scan, MRI scan blood test. MRI scan blood test. And MRI scan blood test ECG. ECG. Okay. Perfect. Okay. Y'all good?
I need help. I'm not sure what.
Okay. You want to share your screen?
Sure.
I'm gonna stop sharing. Let's see. Let's see. Okay, I'm gonna put you up on my big screen.
Okay.
Okay. So you have to start filtering out your data where this condition is met. Oh no, you're in the wrong table. We're in the medical test table. Yeah. And then start filtering out your conditions based off that. Where
But I start with this, like here?
No, because you would keep that select top 1000.
Okay.
Go back, and now what you will do though is in front of line 1, bring it down. And on top of that, document out what you're doing. Yep, now go, yep, now 2 dashes.
Okay.
There you go. Now write your use case in there. So that way you're documenting what you're doing. And this query retrieves the patient ID, test name, like literally list out what you're doing. Yep. Did anyone else want to talk through theirs as well?
I do. I didn't get any numbers or anything.
Let's see. Let's see. Let me see. I bet you, I already know what I think the problem is, but I want to see it first.
Okay.
Probably something similar to last night. I was like, she gonna LOL when I tell her what the problem is. Carla, can you stop sharing so I can see Stephanie's? I can't see both of them at the same time.
Sorry.
It's okay. Why you apologize for that? Don't do that. Don't do that. Don't do that.
Can you see anything?
Yeah. Okay. So let's talk about it. Okay. So the first thing, I like the way you document it out. What I would suggest is finding test results. It's not specific enough because you pulling in where's abnormal and the test date in between. So make sure you capture all that. So that's the only thing with it. Now you got from your table there, that's right. Where result is abnormal, 100% correct. Now, what I will also suggest for you to do is, what I would suggest, the way that I would suggest to counteract this going in the future is take all
Go in order.
Yes, all your conditions, list them down, list them up and down, straight up and down. So you got where test results equals abnormal on line 8. Bring each and whatever your condition is, bring it down. And I'm gonna tell you why. Each line needs to have their own condition. And let's talk about why. We're gonna bring them down, and we're gonna talk. I'm gonna tell you why I want you to do it like that, and everybody else as well, because y'all can apply this too. Now, we got our select from where abnormal. Comment out line 9 and 10. And I'm gonna tell you why I want you to do that. And to comment that each only one line out, you can just put 2 dashes in front of each.
2 dashes.
Yep. Yep. Now do the same thing with line 10. There you go. Now execute your code. Okay. Why did I want you to do that? Because what you're doing, you're taking this whole syntax and you're building upon it. So when I say I want you to build upon it, I want you to start from this. Test this. This works. Now let's add this. So line 1 through 8, it's right. Because look at your output. It reflects what you asked it. So now let's start building upon it. Get rid of your comment on line 9. Now, execute. What the problem is?
The date?
Yep. So let's go back. Comment out line 9 again. What you're doing now is you're now execute. Now, what
So
you're
I'm sorry.
No, because you probably had a light bulb moment. I'm listening.
Yeah, the dates need to be in this order.
Yes, ma'am.
Right here.
It has to be in that structure. So you say where test date equals, but we're not equaling the test date. What we're doing is we're getting a range because I want it in the year of 2024. So if I say a range, I'm saying we're test date between, what is it, 1/1/24, 12/31/24. You need a range.
Okay.
Now, why did I tell you to stack your code like that? Stack your code, huh?
Yeah, so I can see where the error would be at.
Yes.
So that's helpful. Okay.
Yes. When you come in and let's say you have, the more we get in this, like mine is 13 lines of code. Y'all are in session 2. The more you write your code, when you break it down into smaller pieces, it allows you to have a smaller starting point of what was the problem.
Yeah.
So
it
allows you to kind of get like in that habit of, okay, well, this worked, that didn't work. So the problem has to be here. This is where the problematic data is. And it gives you a smaller point to start from to perform a root cause analysis. That's what you're doing. You saw the problem, you're performing a root cause analysis. That means I'm getting to the root of that problem. That's their skill identification. When I'm doing my data investigation to perform a root cause analysis, you've done your data investigation. That's step 1. You didn't get what you expected, so you had to go and perform a root cause analysis. You got to go figure out what the problem is and solve that problem. That's the label to that. That's a root cause analysis. So what you just did in live was you performed a root cause analysis. You found the problem, now you're going to correct it. That's a label for it.
Okay. So I'm trying to see. Because I'm doing between January and December, right?
Yeah, 01. Do 0101. That's right.
Okay.
0101 and 1224, 1230, 224, 1231. That's right.
Okay.
Now get rid of your comment out on line 9. You're gonna get an error because look at your quotes. Look at your strings. I mean, your you don't have a string after 101.
Oh.
There you go. Now, okay, so
Oh.
let's solve that. Now let's add the other layer. You were right for keeping it in.
Okay.
So you put that in back up there. Now execute. Perfect. Now, oh, get rid of 10. Get rid of comment out 10 one more time. And I'm gonna tell you why. Okay, now execute again. Okay, look and see how the actual data for MRI is housed within that table. And look at how your code is structured.
So I'm looking at MRI, right?
Mm-hmm. And look at your code on line 10.
So it should be MRI scan.
Yep. Because in your output, you didn't have any data for MRI because it wasn't structured the same way.
Right. Okay.
And I'm gonna also teach y'all how to test the data, the distinct values as well. I think we do that next session, but shoot, it look like we need to talk about it today because it helps with that. There you go.
Oh, okay. Oh, that was helpful. Okay. Thank you.
You're welcome. I think it gets intimidating when you see the bigger picture and you don't break it down into like digestible parts.
Right.
Like when I say break it down, I mean literally break it down to in ways that like, okay, well, this is where my error comes from. This is where it comes from. Because when you go and you put a big net up there, you catch everything. It's harder to perform a root cause analysis on if you don't even know where to start. So you did wonderful. You did wonderful.
Thank you.
That
was helpful.
It was structured correctly. You used the right ones. I like the way how you using test name in. That was ideal. That's what you're supposed to be doing. I like how you structured everything out. My only advice would be like to layer it out like that. That way you can go and comment out. Okay, this works. Okay, that works. Okay, this works, and just work through it like that. But other than that, you 10-10.
Okay.
How's everybody else? Who is it? Oh, okay.
I structured mine the same way Stephanie did before we corrected it.
Mm-hmm.
All on one line, almost the same way.
Okay.
Except for some weird reason, I blocked out the select and the from. I made that green where I blocked it out. The only question I have right now after we did the corrections and how we structured it is because I was leading more so instead of putting in, I was leading more so or.
Can you share your screen so I can see it in front of me?
Let me see if they'll share. Hold on.
Okay, so you got where test data and test name. Okay, so the reason why it was an in instead of an or, because or gives me these conditions or that condition. For the analysis, I want all of those conditions and this test name and the MRI blood test and the ECG. Now, the way that we can do that, let's actually, now that your screen is up, Are you comfortable with us executing both of those so you can actually see the difference between what both of those return? Or you want me to do it? Okay, let's go then. Now,
Okay.
you got your test name in. You need to put your test name, list out your test name, and test name in. I posted it in the chat. MRI scan, blood test, and ECG.
So type it out like that.
Yep. How Stephanie had it.
And test name in.
Mm-hmm. And then list them out in values and strings. Yep. Make sure you only, it's just a mistake because you did it right the other one. Put only one string in front. Yep.
I don't know why I keep making me retype it.
Cause it's an insert key that you done pressed. And the only reason I know that is because it did it to me one day and I was like over here Googling and stuff. Now execute.
So we did MRI scan, blood test, ECG.
Yep, that's all I got.
I was going by like when you typed in chat, you put the last line is 2024 and the test was an MRI blood test or ECG.
Yep.
That's the reason why I said
I knew that. I knew that. And that's why when I was working through it, I was like, this can be confusing. So I knew that. Because when I was working through it, that's why I like working through the code, which I was like, they can be confused. Now execute that. This will allow us to see in real time what the difference between this and this or. So, okay. So your code, you selected your test ID, test name, all your outputs match. Remember everything, and I'm not saying you because you did this right. Everything after our select statement shows up in our output. Perfect. From this table where this result equals abnormal and test date, you got your values here, and test name in, you got all your values for your test name. Perfect. 100% correct. Bingo. A+. Now, let's change the and on line 11 to or. And then re-execute so we can see the difference.
Oh, I hope it don't make me type this whole thing over.
Press insert on your, it is, Lisa.
Or?
Yeah, or. Oh, well, never mind. You figured it out. Now, execute. Look at your code. Look at your test dates. Look at those results. Look how their output changes. That those two outputs are totally different.
So it's showing me test date. Wait a minute. I don't even know what changed.
Everything.
Everything changed.
Yep. And why? Because you told it where the result is abnormal. I'm gonna bring you to this screen so I can look at y'all. You told it where the result is abnormal and the test date between this or you said and to the top two. Then the third one you came back and said or these conditions or test naming, MRI, blood test, ECG. So you turn around your output and it did exactly what you told it to do. As a matter of fact, get rid of that top 1,000 because it returned 1,000 records, but it's more than it.
You're gonna put all?
You don't have to put anything because when you select, yeah, there you go. Now execute. There you go. So your output can't return back over 7,000 records because you told it where the result is abnormal and the test date between those values or. So I needed to meet those conditions or this condition. And allows you to filter it down specifically. Or it's like, no, give me this or that. That's why they or expanded your output by what? That 7,000 records. Because it winds the net. So that's the difference in real time between the and that or.
So it should be and.
It could be either one, but for this use case, it's and.
More specific to be and. Then.
Yep. Now I did that because I want y'all to see in real time what that difference between that and that or does. It's a world of a difference. It's a world of a difference. Now, while we in here, I can go ahead and use you for the next one.
Okay.
The next thing I wanted to talk to y'all about today, in addition to aggregate functions, which we ain't even touched, was the order by. Order by and limit. So the top 1,000, when we automatically select our top 1,000 records, that is essentially called a limit. It limits the amount of records that's returned. I can do top 1,000, top 5,000, top 50, top 2. It doesn't matter. You can change that structure to fit whatever you need for your analysis. That's limiting data. Now, the second one I wanted to talk to y'all about was order by. You see her output. She has over 7,000 records of code. Now go on line 12 and write order by. Now, when I say order by, it essentially means order by whatever column in ascending or descending order. Now, I want you to order by your test date in descending order.
Should we all be doing this? And
Yeah, you can. You can do it just so you can see what I mean when I say order by. Order by the test date, perfect. Order by that column, and then put descending order, DEST. Now execute. Perfect. Now you see how it gave you the same output, gave you the same logic, gave you the same data. But what it did do is it ordered by that column in descending order the same way you told it to. So that's what that order by is. Order by whatever your column, do AST instead of DEST. And you can see the difference. It'll change it to ascending AST. There you go. And whatever order by that column in either ascending or descending order. And you can apply it to like, you just have to be specific on like which column I'm ordering this data by. So your code actually does a lot. And what we have done today, even we haven't even gone into aggregate functions yet. Data investigation, you have to go through which tables answer this, which columns answer this. Data investigation, structuring your code to say, okay, this is the qualifiable X. Qualifiable means that somebody will come to you and say, hey, I need a list of patients with this condition and that condition. That's qualifiable. You take it and you turn around and write your code to answer that qualifiable X. Because as the analytic professional, that's your job. And people are not going to come and say, hey, can you retrieve this data from this table and use these conditions? They ain't going to come like that. They're going to come with like these type of asks. So you did that. Thirdly, I think, are we on third? Stephanie performed a root cause analysis. Her code, her expected output did not match. It did not execute firstly. And she had to go and figure out what the problem was and solve their problem. That is a root cause analysis. That is what that is labeled. That is what it is called. It is what you did. Not only did you perform a root cause analysis, but you debugged your code. That is what that's called. You fixed it. Within your script, we are retrieving, selecting these columns from this table where these conditions are met. We have gone within filtering, data filtering, and conditional logic. That's where those logical operators come in. Data filtering, conditional logic. So you've done a lot in this portion. And I also want to take the time for you to label what you have done because it makes it real. Any questions?
I have a question.
Okay.
So I noticed So
let me see.
So I noticed like for right here before and, like if I remove the 2 dashes, I get error message. It's like I need both of the dashes and in order for me to get the results when I execute. Is that more like a system or a software thing, like a computer thing? Is that why?
Can you redo it? Can you execute? Can you get rid of those dashes online? Not execute. Oh well, look at the way your test date. It's not the same way it is in the actual. It has to match. It's like test underscore date, and yours says test comp. That's the only problem.
Okay.
Yep. It has to match.
Okay.
Yep.
Okay. Thank you.
You're welcome. So,
Can I get help with mine really quick?
Mhm.
I'm getting an error.
Okay, let's see.
Okay, can you see that?
Yeah. Okay.
I don't know what I missed. I took out the select top 1000. And that's
Look at, okay, so double click. It says incorrect syntax near the keyword order.
Near the keyword order?
Yep,
Right
so
here.
order's on line 10. Look in front of line 10. Look at the end of line 9.
Look at the end of line 9. Okay.
Get rid of that semicolon, man.
Oh, I had it thinking it was the end of the whole query.
Yep, there you go. Now execute.
Okay. But don't I have to put it at the end? Like the semicolon at the end of descending, or no?
You don't have to. Now in DB Fiddle, I think you have to. Some syntax you do. Some dialects you do. But some you don't.
Oh.
Yeah, so
Okay.
that's it. But you know what, Ramonica? I like when y'all be getting errors like that. I love those type of errors. I love the errors that like y'all have had today, because those are the type of errors that like I make. And like people that's like doing the work, they not crazy.
Yeah.
Like it's just like, girl, like this is, and when to me, when you make those type of errors, you get the gist of what it is. It's just like, okay, well, this might have been in the wrong place. It's never, when things get to the point where it's like far off, or like, okay, we doing it from this side. That's when I'm kind of like, okay, maybe we need to like work on something. But the faith is like stuff like what Carla had with the underscore, or what you had with your semicolon. Like that's typical stuff that like I do. So you're good, but it's always, to me, when I see stuff like that, that's good. That's a okay, I forgot my error, but I understand foundationally what I'm doing. Let me see. Am I sharing? Okay, I'm sharing. Okay, so the next portion any other questions? Okay. So the next portion of the next objective of our session today were logical operators and then aggregate functions. So let's get into aggregate functions. So what are aggregate functions? Aggregate functions, they are used to perform calculations across data sets. Aggregate functions is when you get into that data analysis portion of SQL. What's the average of this? What's the sum of this? How many did this? How many did that? Those are aggregate functions. Aggregate functions fall into what it is called data summarization in the aggregation portion of like analysis. What does that mean? You get a dashboard, or you are building a dashboard, or you are the consumer of a dashboard that tells you how many people saw this doctor. How many people have this diagnosis? What's the proximity of how many people live in this city? What's the average of this? All of that ain't nothing but aggregate functions. That is statistics, that is calculation, and that's when we delve into the analysis portion of data analysis. So let's get into the aggregate functions. Also, when in its truest sense, when I compile an aggregate function, that aggregate function is going to return back one record. One record. However, I'm also going to show y'all how to perform aggregate functions, apply those aggregate functions, and categorize that data as well. So we'll talk about that too. So sum, average, count, min, and max. Those are aggregate functions. Sum. A sum does what we know a sum to do. A sum gonna be a sum all day long. Select sum. This is our function. This is the column that we're performing that function on from the table. Average. Select the average. Column name. You got to put that column name in parentheses from the table. Everything go. Y'all see what I'm saying? How everything literally builds upon what we know. Even though we're getting more complex, we're still just selecting this column from this table. Count gives you a count. Notice that this count star here. This count star means give me a total count of all the records, all the columns from this table. Min and max, the same thing. Select max, column name, from table. When I perform any of these, it's going to return back one calculation. Any questions so far? Okay. Group by. So group by, what a group by does is it allows for you to group those calculations into values that make sense. It is used to perform a calculation across a group. What's the sum of this product? What's the average of this price? I mean, this. What's the minimum of this? Like, it allows you to perform that calculation in groups as opposed to across the full data set. So let's get into the syntax of a group by. Here we have our sales table. We got our order ID, customer, amount. This is our sales table. Here we have our syntax for our aggregate function. We are selecting the customer right here. Count. We got our column that we're performing our aggregate function on in parentheses. We say the count of the order ID as total orders. Why do I put this as here? Because when you execute an aggregate function, it doesn't show up in your output with a column name. It's gonna say like no column name. So it's your job as an alias to name that column. So I'm saying select count, select it, count this as this, call this total orders. This is called an alias. No different than how we use alias in our natural language. This is the name, but I'm gonna call it this. That's an alias. So count, we got our aggregate function as this is the alias from our sales table. Group it by customer. So this syntax is essentially selecting a customer, the count of order IDs from this table by customer. And you hear your output here. We got John, got 2. Like, it'll group it by customer. This is in the event that you go and you want the sum of this, the average of this. That's where you get into that analysis part. This is like core data analysis. Any questions? I'm gonna have all this pulled up as you do your as y'all do y'all use cases. Y'all know I'm not gonna like leave y'all hanging. Having, so we have group by and we have having. So having is actually used after this group by. And this goes into Lisa's question earlier about like the order of things. Having goes into after that group by. And what having does is it filters those grouped results based on like the aggregate function. We got where that filters those results based on the full data set. Having filters those results based on the aggregate function. There's two different things. They both filters, but they both perform differently. So, okay. So having is used after they group by. Okay, so we have our select statement, select customer. Sum. We're performing the sum. We want the sum of the amount as total spent. So that output gonna have two columns, customer and total spent. From our sales table, this is our sales table. Group by customer, having sum amount greater than 300. Group by customer that have greater than 300 as their sum. Now you see individually, none of these customers have more than 300 individually. None of these orders have more than 300 individually. So the group by is saying where the sum amount is greater than 300. Because these are customers, neither one of them got more than 300. But when you add them together, they do. By customer, they do. So the difference between where filters the individual rows. Having filters out the aggregate functions. Where individual, where this condition is met. Having, give me a filter based on the total, not based on individual rows. And okay, yep, I also broke down the differences between like the difference between where and having. Where is the individual rows. Having is after you already aggregated it. Where amount is greater than 300. Having some amount greater than 300. Having is filtering for aggregate functions. Where is for the whole data set. This is data analysis. These are your aggregate functions. And notice that they pink because it's a function. It's going to change the way it's structured. It's going to give you something that's totally different than what you expected or than what currently exists. I'll put it like that. So any questions? For this analysis, let's go within our orders DB. These are your databases here. Go within your orders DB. Mine is customer order, but yours is orders. And expand your tables. We are going to lean in on these tables to perform your analysis here.
So we're not in the health system anymore?
No, we're in a different database now.
Okay, I'm lost.
Where are you? Just share your screen.
I'm still in the healthcare. I'm trying to see how to get out.
Oh, you don't have to get out. Just
I still need to share.
that's fine. You don't have to get out. You can keep your code up there. Just click on your orders DB. Just go to your
sorry to interrupt, but the system, I have to re-log into the remote desktop. I don't know why it logs me out. 1 second, sorry.
Okay. Yeah, I don't know why I logged you out either. Let me check on that. But yeah, you can keep your healthcare analysis up there. It's just a different database.
Yeah, but I don't see the order database.
It's called, let me share your screen. Let me see. Yeah, yours still running, Carla. It shouldn't have done that.
Yeah, I just logged back in. Thank you.
Mm-hmm. Okay, now minimize your healthcare system database, Stephanie. Yeah. And there you go, that order DB right there.
Okay.
Yep.
All right.
So that's the one. Okay. This is the new one. Now, why do I do y'all like this? Because in real life, your data will be stored in multiple databases. So I try to mimic as close to real life while I'm teaching you as possible, because a lot of people don't get that level of exposure until you get your first analyst role. And it's like you don't really have a baseline expectation of how to navigate that space for real. So I try, like, throughout it, when I give you different use cases, it's like, okay, that's in this database. But now for this portion, let's go within this database. Because once you get the hang of, like, and you got to do the same thing every time, data investigation, which tables answer this, which, whatever. But that's why I do that, because in real life, that's how it is.
I have a quick question.
Okay.
So did hers just say orders only? Database?
I think so. Hers, y'all say like.
Mine says customers order DB. Is that the same?
Yes, the same.
Okay, I just want to make sure.
It's the same. It's the same. I need to go in. But yes, the same. Y'all should have 3 different databases.
Oh, okay.
Yep, that's it. You're in the right space. You're good, my girl. Okay. Now, okay, so we are in our the orders DB or custom order DB. Now, let me give you a use case. Okay. Now, when we talked about having and where, when I say having, if I'm applying having to the aggregate function itself. That is not to be confused with if I was to perform an aggregate function and I say where the order date is between this. I can perform that. I can put that where. I can use a where and a hold on 1 second. How did y'all get out of y'all bed? Go back upstairs. Go. Did I get out of y'all bed? Y'all got out? Okay, I'm upstairs. Love y'all. I'll be out of the bed. I'm not going to. Mark, can you put that in the bed, please? I'll watch you. I got about 30 minutes left. They got out the bed. That's not funny. Go to your room. Don't touch the bed. Go. All right, I am back. Okay, so where was I? Okay, so that is not to be confused with where. That's not to be confused with. I could say, give me a count of all the customers that are from this city and join between this day. I can say where to this, but I can't say where the average is this. Like if I say having has to be applied to that logical operator. Where I can still apply where to my full data set. So y'all will see what I'm talking about in a minute. So okay, so this is the request. Can you please provide me with the average total amount where the status is shipped and completed and the order date is in the year of 2024? So the first thing you need to do is go within your tables and figure out which tables answers this. Now, we aren't joining data. We aren't doing anything else. So all of these columns will be in one table. So do some data investigation. Which columns answer this? Which tables answer this question?
Which database are we supposed to be in?
The orders DB or customer order, something like that.
So are we working on this now, or are we just looking for the table?
You can start working on it if you find the table. Did you find the table?
I think I found the table.
What table you think it is? I'm gonna tell you.
DBO orders.
Yep. That's it. And actually, let's keep it really small right now. Just give me the average total amount from their orders table. But that's the table though. And we'll build upon it after we get that one. The average total amount. But that is the correct table. So the average total amount. Yeah, good. Oh shoot. Let's see what I did wrong. Okay. Anybody want to share their screen? Or y'all want me to share mine? At least I make it like I don't see the top of your head go like that. Okay, what's up? Let's talk through it.
I don't even know where to start because I don't know, like, if I should just add the average and I'll show you my screen.
Yeah, I was gonna say, because
the average.
Let me see what you're talking about, and then we'll have a baseline.
All right, let me just go delete this real quick because my cursor keeps doing that weird thing again.
Press insert on your keyboard. Literally, insert. It's a button in the middle sometimes. Like it's like.
Oh, I got it. Thank you for that tip.
You're welcome. Because I'm telling you, it called me up bad one day, and I was so mad. Okay, so let me stop. Okay, so let's walk through what she got. Okay.
So I don't have anything really, but because I was deleting things and adding more on, and I was saying, okay, the average. So I'm looking at how the initial way of doing it, you have like average in front of total amount up here, right here.
Yep.
But that wasn't working when I was hitting execute.
So let's talk about why it wasn't working. Okay, so let's don't get rid of them, but comment out every last column except for line 5, because that's what we're going to use to apply our aggregate function on.
So like 2 dashes?
Yep. Get rid of everything except for line 5, and we're going to do a Stephanie. That's what I'm going to call what we're going to do now, Stephanie.
What about this one, order ID?
Get it out of there. Okay. Now, let's perform our aggregate function on total amount. So how are you doing it? Because I know if you...
I was putting AVG.
Correct. Now, open up your paren, because your column has to go in parentheses, remember?
Like that?
Yep. And then close your paren at the end of total amount. Now, let's get rid of that comma in front of line 5. Now, select average total amount as. You got to put as, or let's execute it first, and I'm going to show you why you got to put as. Execute first. Perfect. Now, what this did was it returned back one record of the average of that column for the full data set. Now, the first thing you got to do is you got to say as whatever you're calculating. So as I put average total amount because that's what it is. And the reason why you have to specify is because when you're calculating, the system essentially does not know what you're using it for. So as the analytic professional, you got to make your output as useful as possible, basically. So you got to specify what you're doing. So on line 5, average total amount as average total amount. Put as and then average total amount. You basically are renaming that column. Yep.
After the parentheses is closed, you put as.
Yep. And then whatever your updated column name is. I put
total amount.
Yeah, or whatever, average total amount, whatever you're calculating, put it in there. Because the goal is to make your output as clear as possible.
Total. So would that be together?
Yep. Now put AVG because it's not the actual total, it's the average of it. So put AVG in front of it or wherever.
Wait, as average?
Mm-hmm.
Wait a minute.
Now put that together. Put the average total amount together in one.
Average together with total amount?
Yep.
Like that?
Yep. Now re-execute. Okay.
Wait, that don't look right.
It look right to me. But if it don't look right to you, this is your code. So do it how you want to do it. You want underscore? You want to do underscores?
What am I doing wrong?
Nothing.
Wait, total amount. So it should be a space in between there.
Put your underscore because you can't do that because that's the
like this.
Yep. Yeah, ain't nothing wrong with it, but it's your code, so it's perfect actually. So let's get into what you're doing here. So what you did was you selected the average total amount. Initially, it didn't name that column. It never names those columns in your output of aggregate function. Never. And it's your job to come like how you did on line 5 and say, calculate this as this. Call this column this. So that's
what giving it an okay to change the name of it?
Yep. You're not.
So how would we have known to do that?
Huh?
How would we have known to tell it to do that?
When you perform your aggregate function, mm-hmm. The system never names the output. It always just says no column name. And
because it's only total amount, and so because we want the average, we're telling it we want it to come out as the average total amount.
Yes.
Okay, gotcha.
Yep. It's like the system is so literal that when you are doing your aggregate functions, it never names it, which is why I'm teaching y'all how to do it now. It's never gonna name it. Your job is to come and let me put y'all over here. Your job is to come and okay, this is what I'm calculating. Why does it do that? Because it doesn't know what you're using it for. It's super specific. It doesn't know what the calculation is. It doesn't know, so it's your job to make it useful. But that's exactly what it's doing. It brings back that no column name, and then you got to come and say, name it this. That's the alias. You do the same thing in string functions when you manipulate string functions because you're manipulating the actual value. So I have to come and I have to name it to make it useful. But that's exactly why.
But it's not changing it.
Nope.
Okay, because that's what.
Nope. Okay. It's not changing the column in the table at all. That column in the table is untouched. That's why we say average total amount. This column as this.
So when I do show the data to someone, they would know specifically that that's the average that has been pulled.
Mm-hmm. You're not manipulating the data in the table. That column name is still total amount in that table all day long. In your output, you're manipulating the data in the output. You're not manipulating the database, the architecture. It's the alias. Think about how you use the alias in your day-to-day, in your natural language, what they call it. If I say, hey, her name is this, but they call him that. It's the same thing. Hey, this is the total amount column, but we're going to call it this.
Oh, I just wasn't expecting that. I think that's probably why I wasn't expecting to add a different name. I probably wouldn't have done that if you didn't help me. Okay.
Yep. It's called an alias. It's this, but we're going to call it that.
And that's up to me what I want to give it a name.
100%.
Okay.
That's why when you said it didn't look right, it looked right to me. But that's where the gap is when it comes to memorization and copying to application. You can memorize and copy my code all day. That ain't gonna help you. But if your brain looks at that and you say, well, it don't look right to me, I would rather call it this. You can do it all day long. It's 100% right either way. But the fact that you're doing that, you're applying that. So the fact that you're thinking through that, that's 100% you. That's your thought process. That's your intellectual property. That feels organic to you. That's how you understand it. And you understand it and you applied it that way, and your code is still 100% correct all day long. But the fact that you did that, and that's why I do that. So it's like, okay, how do you do this? Because me and you are different. You and your teammate, y'all might be totally different, but it doesn't matter. So you took it and you said, I would have did it the first. As a matter of fact, I did do it the first way I told you how to do it. That's fine. But the calculation still stays the same. That's where the application piece comes in. What would you do? How do you apply this? What's your thought process? What's your logic? And the fact that you can do it and then turn around and explain it, that means you know what you're doing. That's the goal. So ain't nothing wrong with that.
Okay.
You're right, 100%. Does anybody else have any questions before we add on to that?
Just a quick question.
Okay.
Now, can we use the single quotes if we wanted to, using the alias, like average space, then total space, then amount, put it in the single quotes?
You mean like the column name?
Yeah,
Let me see if you can do that. Yeah, it let me do it. So yeah.
Oh, okay.
Typically I do it just like how Lisa did it though, but it let me do it on my end. I'm gonna share my screen. Oh, you can't see my screen. Yeah, let me do it. But typically I do it exactly how Lisa did it. But if it works and it gave you the same calculation, that's the goal. That.
Okay.
Yep. But yeah, I typically do it exactly how I actually had it like this. Yep, same thing.
Okay.
Yep. But that's where the application piece come into play, because in the field, it's like I might do something different, slightly different. My teammate might do something slightly different, which is also why it's important to document your code, because some people just have different the way they do stuff, and it's okay. But that's where the application, okay, this is how I understand it, so this is how I'm going to apply it, and I can explain this, and it is 100% acceptable. There's not like a step by step way to like write your code. There are some best practices, which is like your documentation, the way you have to structure things, but like the way you write something, that's on you, and it's all good. It's all good. But I like the fact that y'all, like, I can say that like y'all are, the mistakes and things that y'all are having, they're not off base. They show that like you are understanding what you're doing and you're applying what you're doing, and it's like, it's okay. 100% okay. Any questions before we add on to this? Okay. Now, we talked about the aggregate functions. We also talked about group by. Now, one thing that I can say, or one point of reference that we can add when we talk about group by. Group by, like I stated earlier, it allows you to group those rows by that have the same values. Like for example, group by customer. This allows me to get a count of the order IDs per customer, basically. So when I have a group by, anything that I have in my select statement that is not an aggregate function, I have to group it. I have to group it. If I have select customer, or I have count order ID, as total orders, and I want to bring in my amount as well. In my group by, I would have to group by customer, comma, amount. Anything that is not within your aggregate function, I have to group it. Why? Because I'm telling you to calculate this, but I need you to group it by this. So anything that I'm pulling in, I have to tell it how to calculate it and how to group it. So for example, in our current syntax that we have, if I wanted you to group that, if I wanted the average total amount by customer ID, how would you structure your code? If I say, give me the average total amount, we already got our average total amount, but now I want it by customer. So I got my average total amount. I would have to bring over what other column would I have to bring over?
To get the average customer?
Yep, the average total amount by customer. What other column would I have to bring over? I already got my average total amount.
The customer amount?
Ain't no customer amount. What you on the right track?
You said the customer.
Yep, the customer what?
ID.
Yep. So I would have to bring over the average total amount and my customer ID. But since that customer ID is not a part of my aggregate function, I got to group it by customer ID.
Oh, okay. I see what you're saying.
You was on the right track. You was on the whole road, driving straight. And you like, I'm gonna turn left. No, get back on the road. You knew what you were about to say. Select customer ID, average total amount, like how you already had your syntax to calculate the average total amount. From the table, group by customer ID. Do anybody want to share theirs? Am I clicking stuff? I'm clicking stuff. Okay. Select your customer ID. I'm gonna share mine. Hold on, let me pull this out. Okay. So here I pulled the customer ID, the average, just my aggregate function right here, the average as average total amount from the table, group by customer ID. And if I didn't have my group by and I execute it, it's not going to let me execute anyway. It's going to give me a bug because it says the customer ID is invalid in a select list because it is not contained in the aggregate function or the group by clause. So you got to have a group by. And what this output does is it gives you the average total amount by customer. See, we got our customers here, and this is the average total amount. Is this similar to what y'all had?
I did mine, but I got an incorrect syntax near total amount.
Let me see.
So I used the single quote, so maybe I need to change that. Okay.
Yeah, do your average, your aggregate function. Open up your parentheses, put your column name, close your parentheses. Let me see what you got.
Okay.
Okay, so
maybe I need to.
Oh, you know what?
No.
Get rid of your parentheses. I think your parentheses around customer ID, the column customer ID. You don't need that.
Okay.
You also need a comma between customer ID and your average total amount. Yeah, put your comma there. There you go. And now put your other, I guess, let's try that first. Yeah. Now execute. There you go.
Okay.
Yep, it was just the commas around it.
Okay, thanks.
Did everybody get something similar to what Stephanie did? But ain't nothing, that wasn't crazy. Okay. Now, let me get the, where's my stuff? Where y'all go? Y'all still on here? Oh, yeah, y'all still on here. Let me pull you over so I can see. Now, can I get the, now we are going to incorporate logical operators in this. So I need the average total amount where the order was completed in the year of 2024. Now, so therefore I would need the customer ID, the average total amount, and the order date in my output. When you say where, our where would have to go directly under our from statement. From this table, where, we put where before group by, because we're going to filter and then we're going to group. Uh-oh. Oh, let me pull up the logical operators for y'all. Can y'all see the logical operators? Select, we got our columns, we got our aggregate function from the orders your table where the condition is met, group by, and if y'all want to walk through it, we can. Anybody want to walk through theirs or share their screen so we can walk through it together? I feel like you just stuck and want to walk through it.
I can share mine, but I'm gonna send incorrect syntax near
Let me see.
something. Okay.
Let me stop squinting in the screen. Okay, so yeah. Oh, get rid of that comma on line 3 in front of customer ID. Okay, now execute. Okay, now it's saying the order's date is invalid. Okay, so you essentially have to add order date to yep. You got to add order date to the group by. Anything that's not in an aggregate function got to be grouped. Yep. Perfect.
Okay, explain that to me again.
Okay.
Anything that's not in the aggregate has to be in the group by.
Yep.
Okay.
Anything, anytime. Okay, notice how in your select statement we got customer ID, order date, then we got our aggregate function.
Right.
From our orders table all day long, where order date between, you got your range, that's your logical operator. Group by, customer ID, order date. Anything that's not within your aggregate function, you got to group it.
It's in the group. Okay. Yep. Got it. Okay.
Now, why though? Because when I'm performing my aggregate function, I'm essentially calculating. That's all it does. That's when you get into that analysis. That's when you get into that data calculation. But remember how from the very beginning of our query, when we selected the average total amount as average total amount, it brought back the average total. It brought back the average of that whole column for that whole table. When you group it, I'm saying bring me the average, but by these groups.
Okay, that makes sense.
Yep.
Okay, thanks.
You're welcome. You did a good job. And your documentation, I see you. I see you. Anybody have any questions about how Stephanie's code was or how their code is compiled? Okay. Does anybody have any questions for today? Today was kind of heavy. Kind of got out there a little bit, but y'all did good. Any questions? So let's reiterate today's lessons. Today's lesson, logical operators. That's when where y'all at? Okay. Logical operators. That's when we get into that extreme filtering. Advanced filtering. That's when we get into those conditions. That's when we get into the conditional logic. And this condition is met, or that condition is met. Not the end. Those are logical operators all day long. That allows you to filter out your data. That allows you to get an introduction to how conditions met. If this condition is met, I need it all. If that condition is met, I need it all. That's logical operators. The second objective for today was aggregate functions. Aggregate functions is when we get into that analysis part. What's the average of this? What's the sum of that? How many people did this? How many people did that? Those are aggregate functions. That's their calculations. That's their summative analysis part of data analysis. That allows you to really make sense of a large data set. Their summarization. What's the relationships? What's the total? How many of this? How many of that? That's where we get into those aggregate functions. But what we also, within our session, what you are allowed to do is, like how Stephanie did earlier with her data, it did not return the expected output. That happens. So what we focused on today was breaking down that syntax into small pieces. Don't feel the pressure to say, okay, well, I'm doing this, okay, I'm doing it, and chunking all your data out there, all your code out there together, because it makes it harder to debug. So breaking down that syntax into small pieces and building upon as we go. In that, she also performed their root cause analysis. Okay, this can't be the problem. So let's see what this is. Okay, so this is the problem. Let me fix this. Textbook root cause analysis. We do it all day long, but we don't call it that. But in data analysis, that's what it's called. So we touched on a lot of different things today. And I feel y'all did very well, because the errors and things that y'all were getting was like stuff that like I get. And it's just like, oh, okay, let me get this. Okay, let me remove this. So to me, that's evidence that like y'all have been doing your challenges, doing the work, because it's starting to like click a little bit with you. We're like, okay, it's evident. Also, the application part, what Lisa touched on earlier, well, mine was written like this, mine was written like that. That's where the application comes into play. And that's also how a lot of things work over here. It's like, this works for me this way. I feel comfortable with formatting my code this way. It's okay. Because when you're in your technical assessment, when you are doing your technical interviews, nobody is going to come to you and say A, B, C. They're going to come to you with a use case, with a problem, and the expectation is for you to talk through it. This is how I understand. This is what I'm doing. I'm doing my data investigation. I'm debugging. I'm performing my root cause analysis. Just talk through it. And I think today it allowed us to investigate like that whole part of what are some of those expectations are. Anybody got any questions so far? Next week, we are getting into joins, subqueries, and case statements. Those are taking what we have now. Everything we do builds upon each session. Taking what we have now and just stretching y'all a little bit further a little bit more with like some more analysis work. This week, just focus on your coding challenges. If you get caught up on anything, come back and revisit this. What is this recording? And we'll talk through it. Just so I can make sure you feel supported and empowered as we continue to navigate this space. But I think today was a really good session. Ramonica, you had a few errors, but they wasn't crazy. They were just like, stuff that like, okay, this is what I need to do. But I like the direction that y'all are going. I really do.
I have a question. So we can just email you to allow us access to the VPN?
Yeah.
And how long will the recording, will it be up tonight or tomorrow?
The recording?
Yeah, this one, for this class, sorry.
It'll come on like when I end it, when I stop it.
Okay.
Mm-hmm. Yeah.
So I have on my website, I think I have the recording from another session.
Oh,
From
yeah.
our sessions.
So let me talk to y'all about this. So last week, Carla hit me up and she was like, oh, I can't see the recording. So I'm like, what? So I go and look at the recording, and I meant to blast it out for all of y'all. I go and look at the recording, and our recording was like 3 hours last week. So it was too big for the dashboard only allowed like 5 gigabytes or something. So what I did was I took